Hello, my name is Rafael Joseph. Today I will present to you my project that focuses on using PostgIS and ArcGIS Pro to design a spatial database for visualizing the spatial patterns of salinity by comparing different interpolation methods. So, this project implements a spatial database for visualizing the spatial pattern of salinity. It also allows to visualize the location of proposed desalination sites and important marine habitats. And so overall, the spatial database was developed in Postgres, and then a connection to Postgres from ArcGIS Pro was established. And then using the salinity data, this project compared three interpolation method, more specifically kriging, IDW, and natural neighbor. Because I already had existing files, such as the shapefile for the study area, the first step was to create an empty geodatabase or an empty spatial database in Postgres, and then load all the existing shapefiles into the geodatabase. So a software developed by Postgres was used. The software is called Shapefile to Postgres, and it was used to import the study area, the marine habitats shapefiles, and also the salinity data from the T-Explain model. So this project focuses on the year 2011. And for the data that represent the salination plants, the spatial table was created by using SQL code. So after creating an empty geodatabase and loading existing shapefile into it, the next step was to create and populate a spatial table for desalination plants. So in this step, unlike on the previous step where I used a software to load existing file into the geodatabase, in this step I used the query tool in Postgres to write code. So the table was generated using the create table command, and then the add geometry column function from Postgres was used to add a geometry column to the spatial table. These two images show the SQL code that was used to create the spatial table for proposed desalination plants. On the left, we have the code to create the table and also to add the geometry column. And on the right, we have a series of insert commands that were used to create or to populate the table based on an existing Excel sheet that provided the location and also the names of the owners for these desalination plants. The next step was connecting to Postgres from ArcGIS Pro. This step allowed ArcGIS Pro to access the created spatial database that I created in Postgres. So instead of creating this the shape files or the feature classes in ArcGIS Pro, I created it in Postgres, and then I made a connection between Postgres and ArcGIS Pro. After establishing a connection between Postgres and ArcGIS Pro, the next step was to create domain and subtypes. So the desalination plant feature class needed a domain for water and effluent capacity so that I could build validation check for data integrity. In general, desalination plants produce between 10 to 200 million gallons of drinkable water per day, and this table shows a range domain that I created to specify which range of values are allowed for the water capacity fields in a desalination plant feature class. And then I created subtype for the same feature class to represent the status of the desalination plants. So a code 1 was used to represent desalination plants that are active, and a code 2 was used to represent desalination plants that are proposed, which is all the current desalination plants here in Corpus Christi are proposed. And a code of 3 was used to represent the unknown status, which means that we don't know whether it's active or proposed. After that, the next step was to compare different interpolation methods and discuss which one of them produces the best result for visualizing the spatial patterns of salinity. So as we all know at this point, interpolation can estimate the value at an unknown location based on the known values of its surrounding. And in this project, I used three interpolation methods, namely natural neighbor, IDW or inverse distance weighted, and Kriging interpolation methods. So maps were generated for each interpolation method, so that the spatial patterns of salinity could be visualized, and the root mean square errors for the interpolation methods were also calculated for further discussion. After creating and populating the spatial database and also creating maps for each interpolation method, the results are as follows. So in Postgres, we have access to all created feature classes, and they can be shown on a map by using SQL code, and which is the case right here. This figure shows two of the feature classes stored in the created spatial database using SQL code. One of the most important things that I learned in this project, which is something I didn't know before, is that once you connect PostgreSQL and ArcGIS Pro, any changes that you make in a query editor will automatically update the ArcGIS Pro's map view. And this is a very interesting feature to me because I didn't know that. I just learned that doing this project. So for example, if one point is deleted, let's say the circles that you see on the image, which represent desalination plants, if one point is deleted by writing a SQL code, for example, that very same point will also be deleted in ArcGIS. So that's a very interesting feature, especially when you have large amount of data that you want to manage by using SQL code. It's pretty convenient. As far as comparing different interpolation method, what I found is that the interpolation method were able to predict the salinity at unknown locations, and that the surface generated by using IDW and Kriging interpolation method were very similar. The only difference that I noticed was near Nueces River, but for me to notice that, I had to really zoom in and then use the swipe tool in ArcGIS Pro. And other than that, I couldn't really see much difference between the Kriging and the IDW methods. And they both produce the exactly same split in the Corpus Christi Bay, which is slightly different from the natural neighbor interpolation method. And the natural neighbor interpolation method produced the least satisfying result for me, because it was leaving these gaps or areas with no surface near the northeast corner, where you have those circles, these red circles. And for that area, the natural neighbor method was not producing any surface. And that was a little bit, I couldn't quite figure out why that was happening. So that is something that literally needs more research from my part, because I was using the same extent or processing extent in ArcGIS Pro for all of the Kriging interpolation methods. So this figure shows the prediction standard error for creating interpolation method. And what I observed was that close to the individual sample points where we have information from the TX blend model, the prediction standard error was quite low, ranging from about 0.003 to almost 0.018. Whereas where there is less dense sampling, or where we have few sample points, the prediction standard error was very high, reaching about 0.5 units. And the IDW and the natural neighbor methods are not a statistical model, so they do not produce or they do not predict standard error or average standard error like Kriging, which is a statistical method. So in a sense, what this means is that as we move away from the sample space, the error of the prediction increase. The root mean square error were also estimated in this project. And the two figures on the right show the RMSE or root mean square error for Kriging and IDW methods. For Kriging, the RMSE value was 0.037, and for the IDW it was 0.05, which is higher than that of Kriging. So after completing this project, my conclusion is that PostgreSQL and ArcGIS can be used for spatial database design, and perhaps more importantly, they can work together, because changes that you make in Postgres will automatically update the ArcGIS Pro Maps view in real time, almost automatically at about the same time. And based on the maps, I concluded that Kriging and IDW interpolation methods produce the burst surfaces for visualizing the spatial patterns of salinity, and both maps were almost identical. However, based on the root mean square values, the Kriging interpolation method is the best method because it was the one that showed the lowest RMSE value compared to the IDW. So that's pretty much it that I wanted to present. So thank you so much for listening to my presentation, and yeah.